this is our active low-pass circuit which I have drawn in a multisim. So this is the function generator, and this is the oscilloscope to see the signal. And these two multimeters are drawn for to get the output voltage, but it has nothing to do with oscilloscope output. So let's run the circuit. So this is the function generator for the circuit, and this is the oscilloscope graph. I have put 50 Hz as frequency and 1 amplitude. So by examining the output waveform, we can make some observations. So at 50 Hz, since our output signal frequency matches the desired low frequency range, a well-designed low-pass filter should allow this frequency to pass through with minimal attenuation. Therefore, the output waveform should closely resemble the output waveform at the frequency with an amplitude close to 1. This indicates that the low-pass filter is successfully passing the low frequency component. When I try the triangle, let's just stop it and run again. So we can see the waveform is like this. The output waveform is also is in triangle, where the input signal is obviously the triangle. And when I use the square waveform, both are the square, both outputs are the output and the input both are the square waveform. So about the 50 Hz, as the frequency increases beyond the cutoff frequency at the filter, we expect the filter to start attenuating the signal. In our case, we observe that the output waveform exhibits a gradual decrease in amplitude for frequencies about 50 Hz. This is in line with the behavior of a low-pass filter, where higher frequency components are attenuated or reduced in amplitude. So this is the multisim result I've got. By comparing the multisim waveform, I have drawn an Excel waveform as well. So here you can see that I have input a multimeter to get the output voltage. So I've note down the output voltage for these frequencies. The multimeter wave, wait just a second here. So this is our multisim waveform, and this is the waveform we have got from the voltage output. So the multisim waveform demonstrates that the low-pass frequency component 50 Hz of the input signal passed through the filter with minimal attenuation, indicating that the filter allows low-pass frequency signals to pass. The Excel graph displaying the output voltage for different frequencies confirms the behavior of a low-pass filter as the frequency increases beyond 50 Hz. The output voltage gradually decreases, indicating attenuation of a higher frequency components. So based on the observation, we can conclude that the waveform we have observed in multisim represents the characteristic of a low-pass filter. The filter allows low frequency signals such as our 50 Hz input to pass through the minimal attenuation, while attenuating higher frequency components as expected. Okay, so this is the multisim drawing for passive high pass filter. So this is a bot plot to get the output waveform for the passive filter, and this is the oscilloscope graph output, and this is a function generator. So when I run the circuit, you can see that at 50 hertz frequency, the cutoff frequency for this circuit is 30.952 at sine wave. So when I change the waveform, um, the cutoff frequency also changes, which you can see that the cutoff frequency becomes 23.927 kilohertz. And when I use the um, square wave, the cutoff frequency changes to 36.747 kilohertz. So after the cutoff frequency, from the graph we can see that below this cutoff frequency, all are the rejected ones. After the cutoff frequency, it will pass. So after it will pass 1 gigahertz is the limit to pass the signal. So after we change the waveforms, depending on the waveforms, the cutoff frequency also changes. So to conclude, the signal is having different cutoff frequency at different waveforms. That means that this circuit is going to work as a high pass filter as well as the differentiator circuit. So let's compare with Excel output here. So you can see that okay, I'll also show the oscilloscope graph here. um, okay, so this is the oscilloscope graph. You can see that so you can see that the highest peak is on 99.995 volt. So now let's compare with the Excel output. It's also applied the same system for passive filter as well. I have noted the output voltage for this signal. So the output uh, voltage for this different frequencies, we have got this graph. So this is for the graph. Also you can see that after a certain time this signal also increases, it keeps increasing. So this is the graph for our passive high pass filter.